Hey guys, this is just a quick video on how to do this activity so that you don't have any questions about what I expect, what kind of work I expect when you turn it in. So this is an example. This is not the questions you have, this is different questions. So make sure you don't do exactly what I'm doing here, but use it as a guide. So with the question that gives you an equation, here's the equation part. They give you that and they tell you what the y stands for and they tell you what the x stands for. Y is Jane's age and x is Alex's age. So we're going to use this equation to create a table of values. That's the first thing, that's the easiest thing to start with. So if the x is 0, in other words, if Alex is 0, he's a newborn, he was just born, that means that Jane is going to be how old? Well, the equation says x plus 6 equals y. So if the x is 0, we'll type in 0 plus 6, and that's going to give me 6. That means that Jane was 6 years old when Alex was born. And if x is 1, or if Alex is 1, that means Jane turns 7 because we have to add 6. Same thing for whenever Alex is 2, now Jane is 8. Now these are the values that you're going to graph. So the value for x and y would be the order pair 0, 6, because that's the x coordinate and the y coordinate, and then 1, 7, and then 2, 8. Notice that your graph has nothing on there. So first thing I want you to do is I want you to draw the x-axis and label it x-axis, and then draw the y-axis and label it y-axis. Okay. I'm not going to make you label the origin, but know that this point right here is the origin, so I'll go ahead and put a 0 there because that's where everything starts, right? Now notice this is how you're going to number your table, your grid. Notice the highest number that you have right now on the y's is 8, and the highest number you have for the x's is 2. You don't have to stop there, but that's what we have right now. So that's all you are required to do. You can do more if you want to, but right now I know that I need to count all the way up to 2, starting at 0 on the x. So I could do 1, 2, 3, but that means I'm just going to use the first 2 lines or the first line, the second, and the third line for graphing these 3 points, and that's going to be all my graph is going to be squished right here. So instead of doing that, I'm going to count 1, 2, 3, 4, 5, and the fifth one, I'm going to put a 1 right there. And then I'll count 1, 2, 3, 4, 5, and then this would be a 2. That way I can use most of the graph. I can spread out the points. For the y-axis, the highest number you have is an 8. So that means I'm going to count by 1s or 2s or 3s or 4s. If I count by 2s, let's see, that's 1, 2, 3, 4, 5, 6, 7 and a half. So 8 would be way up here. So I don't want it to go above my axis, so I'll just count by 1s. So this is 1, and that'll be 2, 3, 4, 5, 6, 7, and 8. So those are all the numbers that I need on my x and my y-axis, because now I can graph these points. 0, 6 would be 0 on the x-axis, and then up 6. So the very first point that I have would be this point right there. And the next point that I would have is 1, 7. So 1 to the right and up 7 would be right there. Nope, it would not be right there because my 1 is not right here. Remember, my 1 is way over here. So I have to go all the way over here 1 step and then up 7. This would be my second dot. So be careful when if you are going to make your graph like I did, you might make this mistake. You have to know exactly how many steps you have to take. And this is 1 step, and the whole step goes from here all the way to there. Okay, so then 2, 8 would be all the way over here to 2, and then I'll go up to the 8 line, which is right there. So if you connect the dots, it will look something like that. Hopefully it's a straight line. Mine is not very straight, but you get the idea. Now, then you have graphed the table, and you put the dots on the graph, and you have the equation. The last thing is to do a verbal description. So the verbal description is just like a word problem. So you're going to use what you know to make up a word problem. For example, here we know that Jane's age, right? Jane's age is equal to whatever Alex's age is plus 6. So we're going to say that. We're going to say Jane is 6 years older than Alex. And that's it. That makes sense. Now the word is a key word that you might want to pay attention to, because the word is kind of like your equal sign right there. Okay, that's going to help you whenever you write your equation. And it's 6 years older because we have to add 6 more. Does that make sense? Okay. So now we're going to write about the independent and the dependent. Remember, when we talked about the independent and dependent, this is just a review from 6th grade TEKS. When the strategy is dry mix with the D for dry and the I for mix. So that coincides with our X and our Y axis. So we'll put the dry up here and then the word mix right here on the X axis. Remember that D stands for dependent. Dependent, okay? And then the I in mix stands for independent, or in other words, the one that is in control. So in this problem, the independent turns out to be whatever's on the x-axis. And here the total x was Alex's age. I'm going to go ahead and write that down right here. Alex age is the x-axis numbers. And over here on the y-axis is Jane's age. So I can turn my paper and I can say these numbers right here represent how old Jane is. Jane's age. Okay, so I'm going to turn back around. Now you can see what I'm talking about. So now you can say, okay, well, the dependent variable is the one on the y-axis because of the strategy dry mix. So Jane's age depends on Alex's age because that's the independent. So the independent variable right now we're going to put is Alex age, and the dependent is going to be Jane's. And the question is, does it contain the order pair 0, 0? Remember, 0, 0 would be this point right there, the origin, and this line does not go through the origin, so it does not contain the order pair 0, 0. Which means that if by looking at this graph, if we did not have this equation or the pattern that we could figure out by looking at the table, then just by looking at this graph right there, it tells us that we have to call it an additive relationship. And I want you to write that right here, relationship, for your final step. I know this doesn't have that question, but I want you to include that so we can practice identifying an additive relationship versus a multiplicative relationship whenever you have all four forms of the same problem. This is just the word form, that's the equation form, that's the table form, and that's the graph. But every single thing represents exactly the same thing. So this is why this is a good practice for this station. All right, sometimes you don't have the equation like this one. Sometimes they give you the verbal description, like Cindy is 4 years older than Travis. So just like we did before, where you're going to use that word is as a keyword, we're going to say that's my equal sign. Cindy is, so usually Cindy is by itself because it's going to be Cindy is equal to. And if you notice what our equation looked like over here, the variable that is always by itself is just the y. So that means that Cindy is going to be the y variable. Okay, and is 4 years older than Travis. So that means we're going to say Travis is going to be the x. And what do we have to do to the x? If it's going to be 4 years older, we have to add 4, right? Okay, I'm running out of lead. Okay, so 4 years older. So there's my equation. Y is equal 4 plus x. Now remember, we can switch these numbers around and we'll get the same answer, like 4 plus 2 would be the same thing as 2 plus 4, right? So it doesn't matter if you write 4 plus x or if you write x plus 4. Kind of like this one, they wrote the x first and then the 6. Here I wrote the 4 first and then the x, just because I used the way that the problem is written. But you can write it either way because of the commutative property. So the x, now we know, represents Travis's age. And we can write that down. And then Cindy's age would be y. Okay, the equation, well, we just copy down y is equal to, and I'll go ahead and say x plus 4. I'll change those around so we can see the equation. I'll make that equation sign a little bigger so we can see it, and I'll box it in. That's my equation. So I'm going to use that equation to write down my table of values. Okay, so when x is 0, in other words, when Travis is 0, Cindy is going to be 4 years older, which is going to be 4 years, right? Like that. And then whenever Travis is 1, Cindy is going to be 4 years older still, so she's going to be 5. And then when Travis is 2, Cindy is going to be 6. So the order pairs that you would graph would be 0, 4, 1, 5, 2, 6. You get the idea. You go ahead and write down your x and your y values. Find out which one is the independent, the dependent. Tell me if it contains the 0, 0 order pair, which is the origin. And tell me the type of relationship here by looking at your graph, by looking at your table, by looking at your equation, and looking at your word problem. You can identify what kind of relationship this is. The equation is the obvious one because it tells you what you're doing. The table, you have to find the pattern, which is inside the equation. And then the graph, you have to look at the lines to see if it crosses the origin. Remember those little tips. All right, and then sometimes you're going to run into a question that looks like this, where they give you the graph. So if they give you the graph and everything else is blank, well, you have to come up with the numbers here. And the dots that you're going to use, please don't use this dot right there because I don't know what this number is going to be right there. This is 1. So I'm guessing this is 0.5. But then this number is going to be what? 0.3, 0.4, 0.39? I have no idea what that's going to be. So I'm not going to use a point where it crosses this line, where this line crosses the first line going up like that. I'm going to use a point where it crosses exactly at the corner, like this one. Okay, so this is going to be my first point, actually my second point, because you can probably see already that it goes through the origin. So that's going to be my first point, second point, and then you can see that this one crosses right there, keep going up, and it crosses right there, keep going up, and it looks like it's going to cross right there. So that means that we have these 5 points, and I don't even need all 5, I just need 3 points. So the first point would be 0 for the origin, 0, 0 for the x and the y, and then the next point would be 1, and then go up between 10 and 20, that would be 15, right? So the second point would be 1, 15, and then there would be 2 and then 30, right? So 2 and 30 for the y. Those are the order pairs that we graphed. So 0, 0, that were in the graph. We didn't have to graph them, so we're just going to write them down here as order pairs. So we're done with that part, the table. Can you find a pattern to help us write the equation? Well, I know 0 times something will give me 0, 0 times anything really. So this one's not going to help me, but this one might. 1 times something equals 15. Well, anything multiplied by 1 is the same thing, so this number has to be 15. 1 times 15 is 15. And we can check it with the 2. 2 times 15, that gives me 30, that works. And then if I multiply it over here times 0, 15 times 0 is also 0. So that works. So that means that the pattern is times 15. Whatever the x value is, multiply times 15. I'm going to write that down right here. Whatever the x value is, I'm going to multiply it times 15. And that's going to be equal to my y. And that's my equation. I can write it like that. Or the more correct way, since you're in advanced math, would be writing down first the number and then the x with no multiplication symbol in between, because that is understood that is multiplication. So the equation actually looks a little bit shorter. It looks like that. Y is equal to 15x, which means 15 times x. Same thing, it just looks a little different. Now we're going to define what the x and the y variable are. And this is where you can have a little bit freedom. You can choose whatever letter you want to become whatever it is that you're talking about. But you have to remember one depends on the other. So remember, the dry mix strategy. The independent, the one that controls the other one, is going to be the x. So for example, the x is going to be how many hours I work. Hours of work. Okay, if I work at, I don't know, at the mall, in a store, folding clothes or something like that, then the x is going to represent how many hours I work. And the y is going to represent how much money I earn. Money earned. And now that I've identified those, and like I said, this is kind of freedom for you, but you have to think about what's going to be your dependent and what's going to be your independent. What depends on the other? So that's kind of part that is going to be affecting you right here. So on your x-axis, then you would put this is numbers right here are the hours, and these numbers right here, make sure you label the y-axis. These numbers right here are going to be the money earned. Which means that if I work 0 hours, I earn $0. That makes sense. If I work 1 hour, I end up with $15. If I work 2 hours, I end up with $30. 3 hours would be $45, and 4 hours will give me all the way up to here to $60. And I can keep on going. The more I work, the more money I make. That makes sense. Okay, so the independent variable would then be the one in the x-axis. That's the hours. The dependent is the money. It depends on how many hours you work, and it does cross at the origin. So that means this is going to be a multiplicative relationship. Okay, so hopefully you have identified that in its multiplicative relationship because it does cross through the origin. It does contain the order pair 0, 0, and it also, over here, we can see that it's being multiplication. So the last thing we have to do is fill out the verbal description. So since we're talking about hours and money, we can say, I don't know, give me a name. Miguel works at the mall and earns $15 every hour that he works. Okay, so that's the verbal description of what we just did. He's working at the mall and you're making $15 every hour. And then the last one is here, is a table. But I think you can go from here. I think I don't need to work this one out because I think you're pretty smart on finding the pattern, using it for the equation, graphing the points accordingly. Make sure you label your x and your y axis with the labels, like the numbers and the actual names, x and y axis. And then tell me what the numbers represent, okay, once you make up your verbal description over here. And then make sure you tell me if it's dependent, independent, if it contains 0, 0, and what kind of relationship it is. Okay, hopefully this video kind of helped you, especially if you were like out of the classroom, if you were absent, if you didn't join the class yet, or if you went somewhere for a long time. Yeah, you know who I'm talking about. All right, have fun. Hopefully this helped you.